Hi all, myself Dr. A. Nirmala, Associate Professor, Department of Computer Applications. Through this video, I am going to discuss about clipping concepts in computer graphics. So in this video, point clipping, line clipping and polygon clipping. We are going to discuss about these three clipping procedures. Let us start with the definition of clipping. So the clipping is nothing but a procedure that identifies the portions which lies inside the window or outside the window. Window is nothing but an rectangular area. It defines what object is to be displayed, whether the whole object or any portion of the object is to be displayed. That defines by the rectangular area on the screen. That is called as window. So clipping is nothing but a procedure. It is used to identify the portion of the picture that are either lies inside the window or outside the window. So the region against which an object is clipped is called clip window. Next one is the point clipping. So clipping is nothing but we have to check, we are calculating or we are finding the given particular pixel value. The point lies inside the rectangular area or outside the rectangular area. So the window has its own minimum and maximum values. So the point should lies between the minimum and maximum values of both x-axis and y-axis. Then only the point will be saved and displayed on the screen. Otherwise, that will be discarded. That will not be displayed on the screen. So let us assume that the point P is equal to x comma y for display if the following inequalities are satisfied. xw min less than or equal to x less than or equal to xw max. Like that, yw min less than or equal to y, yw max. That means x and y should lies between the minimum and maximum value of the window boundary. Then only it will be saved and displayed. And next one is line clipping. So we know that to create the line, we need 2 points. One is the starting point, another one is the ending point. So we need to check whether both the endpoints of the line lies inside the window or it lies outside the window. Or is there any intercepting between the boundaries and the line. So we have to check. The clipping procedure involves in the three categories. That means both the endpoints of the line lies completely inside the clipping window. That means the given line lies inside the window, and it may be lies completely outside the window. That means both the endpoints can be completely outside the window. Or else, apart from these two cases, we have another case like performing the intersection. If there is an intersection between the boundaries of the window and the line, we need to perform intersection calculations with one or more clipping boundaries. So all these things we can process through the inside-outside tests by checking the line endpoints. So here is an example for line clipping. The first diagram shows before clipping. Here we have 5 lines. In the top of the window, we have the line like both the endpoints lies outside the window. So these 2 points will not be saved and will not be displayed. Like that, the left side of the window also we have one line segment that also both the line endpoints are lies outside the window, so that will not be saved and displayed. But both the endpoints in P1 and P2, the line which lies inside the window, so that can be saved. We have to check whether the P1 lies inside the window and also P2 lies inside the window. Then that line segment, the points will be saved and displayed. And the next case, P5 and P6, only the second point lies inside the window, the first point lies outside the window. So that we need to perform intersection calculation against the left side boundary of the window. And in the last case, both the endpoints lies outside the window, but the line segment, part of the line segment will lies inside the window. So in this case, we need to perform intersection calculations against the bottom boundary and the right boundary of the window. So after calculating all these things, we can have the lines after clipping, which is shown in the right side of the slide. And we'll discuss about Cohen-Sutherland line clipping algorithm. So this algorithm is used to clip the line which lies outside the window. Okay, so it is detected whether line lies inside the screen or outside the screen. Screen is nothing but the rectangular area. All lines come under any one of these categories. That is visible, not visible, clipping case. In visible category, if a line lies within the window, that means both the endpoints of the line lies within the window. So the line is said to be invisible and that will be saved. The line endpoints are saved, that will be displayed on the screen as it is. And in the second category is not visible. If a line lies outside the window, it will be invisible. That means both the endpoints lies outside the window and that are rejected, that cannot be saved, that will not be displayed on the screen. And how we can identify the line endpoints or lies outside the window or lies inside the window means we have to check these conditions. If any one of the following inequalities is satisfied, then the line is considered as invisible. For example, let us take A x1 y1, B x2 y2 are the endpoints of the line. So x min, x max are the coordinates of the window. That's minimum and maximum of the x coordinates. And y min, y max are also the coordinates of the window. So we have to check x1, y1 and x2, y2 lies inside the window or outside the window. If x1 is greater than x max means obviously it lies outside the window because the point should lies between minimum and maximum values of the boundary. So here x1 greater than x max or x2 greater than x max, like that y1 and y2 greater than y max means it is beyond the maximum value of the boundary. So that will not be saved. Like that it should not be less than the minimum value also. If x1 less than x minimum, x2 less than x min and y1 and y2 also less than y means those points also not saved because that point should be lies between the minimum and maximum value of the window boundary. Then only these points will be saved. Otherwise, it will be considered as the invisible. And in the third case is clipping case. If the line is neither visible case nor invisible case, it is considered to be clipped case. That is, we need to perform intersection calculations. In Cohen-Sutherland line clipping algorithm, we are assigning the 9 regions, assigning the region code for 9 regions. Each code is of 4 bits. If both endpoints of the line have end bits 0, then the line is considered to be visible. Here is an example for the 9 region 1, region 2, region 3. That is, the rectangular area is divided into 9 regions and we are termed it as region 1, 2, 3, etc. 9. So the center region 5, which has the code 0, 0, 0, 0. So that means the line endpoints it lies inside the window means that should have the region code as 0, 0, 0, 0. Otherwise, that will be considered as the, for example, 1001 region code is assigned to line endpoints means that lies top left of the window. So it then 1000 represents the top of the window. Like that, we can assume that the particular endpoints lies within the region or it may be falls under any these other eight regions. So according to that, the endpoints can be saved or clipped. So here it is an example, another example. Let A, B, I is in the visible case because both the endpoints are lies inside the window. If we are assigning region code for these two endpoints, we will get 0, 0, 0, 0. 4-bit region code is assigned. So if the region code is 0, 0, 0, 0 means the particular line endpoints lies inside the window. So according to that, we can define like line OP is invisible case because both the endpoints lies outside the window, top of the region. And line PQ is in invisible case. That means both the endpoints are lies the region top right of the window and also the right of the window. So those two endpoints will not be considered. Like that IJ, MN and CD. So according to that position, that line endpoints can be discarded or saved. And next we'll discuss about the polygon clipping. A polygon can also be clipped by specifying the clipping window like line clipping. Sutherland-Hodgman polygon clipping algorithm is used for polygon clipping. In this algorithm, all the vertices of the polygon are clipped against each edge of the clipping window. First, the polygon is clipped against the left edge of the polygon window to get the new vertices of the polygon. So, this following figure show left, right, top and bottom edge clipping. First, the polygon, given polygon, that is the input polygon is given to left clipper. The left clipper, it processes the left side the polygon and which lies outside of the window. It clipped that part, only the left side of the region. Then after that, it calculates the new vertices for the left region, and along with the new vertices, it will be given to the right clipper. Then right clipper identifies the portions of the polygon which lies right side the boundary, outside of the right boundary. Then again it will be clipped, new vertices are calculated, then it goes to the top clipper and bottom clipper. So all the boundaries, the process against all the boundaries are processed, and the polygon which lies outside the window, that is the vertices which lies outside the window, will be clipped, and that will not be saved. Only the new vertices which are calculated during the clipping process, that will be saved and displayed on the screen. And it is performed by processing the boundary of polygon against each window corner or edge. There should be the following conditions while we clip a polygon. Condition 1. There may be the chance to the vertices, that is edge, out to in. The first vertex lies outside the window and second one is lies inside the window. In this case, only the output list will be created with that can be included the new vertices, that is v1 dash will be calculated because it is intercept with the boundary. So the new vertex v1 dash is calculated, and the new vertex and the second vertex will be added in the output list. V1 will not be added in the output list because it lies outside the window. And in the condition 2, in to out. That means the first vertex is inside the window and second vertex is outside the window. In this case, only the inside vertex which are stored, that will be added in the output list. And in the third case, into in. If both the vertices of the polygon are inside the window, then the output will be the second vertex. The second vertex will be added to the output list. And the condition 4 is out to out. If both the vertices of the polygon are outside the window, then the output will be nothing. It means we found a clipped polygon. So these are all the 4 cases we are facing while clipping the polygon. So before clipping, the diagram is like this. Here it shows that the sum of half of the boundary, half of the polygon lies outside the boundary. So we need to calculate the new vertices in the edge AB and as well as in the edge GF and CDDE. So after calculating the new vertices, that all the vertices are added with the output list, then with the calculated vertices and the original vertex, we can get the polygon like after clipping, we will get the polygon like this. So in a nutshell, through this video, we have discussed about point clipping, line clipping and polygon clipping. I hope you have some idea about clipping process in computer graphics. Thank you for watching this video.